but I'd like to start off just by saying welcome to the final meetup of the Tech and Tie-Dye community for 2020. We're really excited that you've come on this journey with us from March at the beginning of this year to where we are now. We're really proud of the progress of this little meetup community, and starting a couple of weeks ago, we've had partners, some of our tech partners, knocking down the door trying to get a slot for 2021, and we want to see how this grows, and we want to see what's valuable to the community. And exactly that is why we've got two amazing sessions planned tonight, but I'll touch on that right now. And you can see my screen, right?
Yeah.
So the agenda, I'm just going to just go through what the Tech and Tie-Dye community is for all of our new members, and then just going to introduce our amazing speakers for the evening. So for anyone that hasn't been to one of our meetups before, the Tech and Tie-Dye community is a place where it's an open and inclusive community where everyone has a seat at the table. We share ideas, we learn together, and we get the opportunity to connect with each other. And it's important that we kind of create our own narrative with where we want tech events to go. And this is exactly what we're trying to do with this community. We've got Doug and Mark from the LSD data team, who's going to show off Elastic Cloud for Kubernetes for cloud native deployments. So Doug and Mark are Elastic and observability experts. You might know them from the Elastic SA community. They've been putting a demo together over the last couple of weeks, and we're really cool to see some cool Kibana dashboards and some shiny things. I see Doug just joined the call now, just in time. But yeah, thanks. From our side, just you don't have to feel like you have to attend the tech session if you're not so inclined. We won't feel bad. We know sometimes it's, some of these rocket scientists can go a bit off script and tangents, and but we really just want to thank you for joining us, taking some of your personal time, and for joining any of the meetups this year. Thank you. And we'd like to invite you to join us again in 2021, where we head to Cloud Native Nirvana, and we'll tell you some more about that in the coming months. Hey, so yeah, Mark and Doug is from the LSD data team. They experts in Elastic and observability, and I can't wait to see some rad dashboards tonight. So yeah, I'm gonna leave it over to Mark and Doug.
Okay, guys. So today we're going to chat about, we're going to go technical now, so we're going to have to kind of flip our mindsets a bit and chat about Elastic Cloud on Kubernetes. And this is specifically speaking around observability in cloud native deployments. Just very briefly, I'm Doug, and then I've got my colleague Mark, who's going to be presenting the demo. I'm just going to run through a couple of quick slides with you guys to just to set the scene a bit, and yeah, we're both part of the LSD data team, so we do a lot of work in this observability space, working with Elastic and deploying it for customers and doing all this kind of cool stuff. So so we've had a lot of experience in the space. We understand where what customers are doing today and what the direction that everyone's trying to move in. So this is all kind of right in our breadbasket. So before I get into LSDobserve specifically and to sort of set the scene on this, I wanted to just start off by sort of framing where observability sits in this sort of cloud native space, specifically for LSD. So Dion presented this at a previous meetup. I know some of you may not have been there. So I'm not going to go into this, what we call our LSD trip, into any detail. This is specifically focused on observability. But as I said, just to give you an idea of where this fits into our landscape, I thought let's just put a quick slide up. So just very briefly, the LSD trip is basically our set of fully managed solutions designed to enable this modern digital modernization and get customers to sort of a fully cloud native state. So we have this trip specifically designed with that in mind. And we sort of, if you look at the various aspects of it, we have a sort of map where we have a look at customers' sort of individual maps or paths to cloud native. Everybody has a different journey. LSD Container looked at the sort of from the Kubernetes platform, and obviously sort of a fully managed environment. LSD Automate is looking at your sort of fully managed CI/CD and cloud automation tool chains, and then obviously LSDobserve is where observability fits into this picture. And this is where I'm going to focus a lot, and is basically giving you that observability platform across all of these various moving parts. LSD Data Streaming is our sort of real-time event streaming platforms. Secure is sort of managing your secrets, policies, SSO, vulnerabilities, so sort of your fully managed cloud native security platform. And then Connect is looking at API and service mesh platform. So basically all of these things together form our LSD trip. And as I said, we'll get, if anybody wants a deeper dive into this, that's an entire session on its own, and we're happy to set something up. And a colleague who's been on the quite active on the chat, DJ, he can he's the master on this one, so you can run you guys through this. But let's move on to the observability space. So if you look at the landscape, software has become a lot more complex in sort of than it ever was in the past. With I mentioned earlier, there's a lot more moving parts to this. Moving from monolithic apps hosted on VMs to sort of your Microsoft microservices and containerization architectures. There's so much more that we need to be aware of to have effective observability in this area. So, I mean, that's everything from, your on the metrics from, containers, host, network storage, APM, your transaction performance monitoring, distributed tracing, your logs, everything from app logs to infrastructure logs, and obviously your service uptimes and response times. All of these things form part of this observability landscape. And so what we typically see is a situation like this. So we would have, there's very typically, there would be this sort of swivel chair approach. That's why I popped a swivel chair in the middle there. But we'd have Ops team, looking into infrastructure monitoring. They'd be logging into a metrics platform, something like Prometheus for Grafana, which is very popular. There are many more too, and also really good at what it does. On the logging front, Elasticsearch is very popular. That's sort of obviously a basis of what we're talking about here today, but just in the context of what we're seeing Elasticsearch used quite a lot on the logging front, and typically see ops people on doing log monitoring, ops team logging into Elasticsearch when they need to find logs. And a similar story for service monitoring and logging into some other uptime tool. Then we have our development team logging into a completely different tool for APM. Sometimes it's Jaeger, and there's also a number of other tools available. So the big question to answer in this then is, does this multiple tool approach make sense? And we can sort of analyze this. There's a lot of points to it. We can look at stuff like maintaining multiple tools operationally, the diverse sets of skill sets you'll need for multiple platforms, complexity involved with having multiple platforms, data governance when your data is now in multiple platforms. Obviously, there's cost things to consider, licensing costs, storage costs with multiple platforms. There's also, considerations as well. I want to use the best tool for the job. So, APM, I think this is the best. It's a dedicated APM tool. So there's considerations on the other side of this too. But at the end, if we look at what the observability space is, and now to answer this question, it really comes down to how quickly we can pick up that there's a problem in our environment and how quickly we can solve it. That is the most crucial thing in this entire environment, and is what really makes a difference in this observability space, and how we position observability in using sort of a single platform approach. Often troubleshooting something, something happens, you troubleshoot it, takes you on this trail through, you're troubleshooting through uptime, through logging, through metrics, through APM, or a combination of all of those. And having these things under sort of a single pane of glass where you can correlate between APM events and container metrics and logs and whatever else you have, just creates a much more productive workflow, and ultimately a much faster time to resolution, which to us is absolutely critical in this kind of space. So this is basically where LSDobserve comes in. It's our approach to observability, and where we typically have your dev and ops teams who have now turned into ninjas, and they're all using a single observability platform, so a unified platform. They have unified skill sets, and they have unified views over the entire observability landscape. Whether it be logging your logs, your metrics, your APM, it's all part of the same thing and correlated together, shown on the same dashboards and with the same pane of glass. And obviously, effectively leads to much more efficient monitoring to resolve problems, like we've discussed. So, this is where Elastic plays a pivotal role for us. I think I've mentioned Elasticsearch. I haven't really said what it is specifically. I've said it's been used for log monitoring, but I think a lot of people on this meetup will probably already know. But it's, as I said earlier, it's very prominently used in the log monitoring in the Kubernetes space. Very often it's baked into Kubernetes management platforms to handle the logging aspect of it. But it's also, if you look at the entire Elastic environment, it's also very strong in APM, uptime, and metrics. And it's also built with a sort of complexity of the cloud-native landscape in mind, with a lot of curations on the ingest side, with Beats that understands the environments, curated dashboards which Mark will show you a bit later, so I'm not going to dive too deep into that. And so that's basically Elastic's capabilities around this space. And then if we look at what Elastic Cloud on Kubernetes, which is shortened as ECK, that's basically a deployment model for Elastic, for the whole Elastic platform designed for Kubernetes. You deploy Elasticsearch, APM, Server, Kibana, to pods using Elastic Kubernetes operators is the basics around it. And it also adds this orchestration to Elastic. So obviously making clusters far easier to deploy, and obviously scale to purpose, meaning a lot more efficient utilization of resources. And then also one-click, upgrading, easy upgrades through the operator, and sort of specifically designed this orchestration around the Kubernetes platform. And obviously, that gives you the ability to also deploy multiple clusters for different use cases too. Elastic is a platform that's built with sort of three main solution pillars or curated solutions in mind. And the one is over this entire observability landscape, but there's also security, where there's sort of built-in SIEM products that wanted to take use of for sort of security landscape and endpoint protection. And then also there's searching capabilities. Under the enterprise search banner, there's a whole bunch of stuff. They're each a presentation on their own, so I'm not going to go there. But there's, the Elastic's often seen as this sort of Swiss Army knife that you can do a lot of stuff with. And having a dedicated ECK deployment allows you to take advantage of that. And another thing to just discuss here briefly is so I know Elasticsearch is often baked into some of these Kubernetes platforms, and we often get asked, why can't we just use the baked-in version to do all of this cool stuff? And we've got a fair bit of experience here, and these baked-in versions that they have are designed to fulfill a very specific function. There's very often log monitoring with very limited functionality, and it's typically a lot of sort of lockdown functions. It's not designed for end-to-end observability platform and to deliver on elastic use cases. The versions are always usually updated because these things are directly baked in or integrated into these systems, and often also pretty difficult to support because of their sort of fixed nature. So in order to take advantage of being able to handle this whole sort of end-to-end observability, you need to get this a dedicated ECK platform. That's our advice. It's obviously what we do is based on open source technology, and of course is a really good platform that we use together with LSDobserve to create these solution spaces. On the ECK side, it provides sort of these free forever basic license that Elastic provides, which gives you a hell of a lot more features than you'll ever get in these baked-in versions. Like I mentioned SIM earlier, you also get the index management stuff like ILM and sort of your full range of APM features and functionality. You get the APM app, the distributed tracing. So all of this stuff is not there and just not available in the Elasticsearch stuff that's baked in. And yeah, so I think that's basically all I wanted to cover with you guys. I don't want to go into too much depth here and bore you guys too much. I think it's demo time. So Mark has set up a demo running on one of these Kubernetes environments. He'll show you guys some of the stuff I'm talking about, looking at disparate systems for logging, and then also looking at, what does an observability space look like when you bring everything together. So that's me. I'm going to stop sharing my screen and allow Mark to jump in and take the reins.
Cool. So, as Doug mentioned, there are various Kubernetes management platforms. Some of them have out-of-the-box observability components that you can enable, usually using Ansible scripts. Others have fairly bare-bones observability, often homegrown, and others have none at all. The platform itself's there, but the feature set's very limited. So ECK, Elastic Cloud Kubernetes, is completely platform agnostic. So in this case, I've deployed it on OpenShift just because that happens to be what I'm most familiar with. And OpenShift's one of the platforms that has out-of-the-box observability components that you can enable very easily using a set of Ansible scripts. And that's what I did here. So I enabled OpenShift logging and OpenShift monitoring. So you can see there's a set of pods running. The Grafana pods, the metrics, GUI front end. We've got Elasticsearch for storing logs. We've got Fluentd for collecting logs. We've got Kibana for viewing logs. Prometheus for storing metrics data. And that's all good and well. It works just fine. You can, okay, well, that's the first thing. The second thing is I've deployed a Spring Boot app that I've, for the purposes of instrumenting it with APM. So if you want to start looking into the observability side of your Spring Boot app using the out-of-the-box Red Hat provided observability components, you can have a look at your pod, and you can see here there are some metrics. So there's some CPU usage, memory usage over time, network usage. And then the logs you can see are here. So there are the logs streaming. And if you want to look and be able to search through your logs, you can always just view archive, and that's going to bring up Kibana. And it'll be pre-filtered for the namespace and pod name. And there are your logs. So this was right now, a minute ago. And then you can add queries to your search. And for example, I want to look at errors, and I know that there's a component in my Spring Boot app called Crash Controller, so I can do that, and I can look at errors. And it defaults to the last week, so I'm just going to change that to the last half an hour. You can see that we've got errors happening all the time, and that's because in the background I've got a Selenium script that's just randomly clicking on all the components of this app. And that's great. There's your logging component of observability. And then of course there's the metrics component of observability. So this is Grafana with Prometheus as its data storage backend. So we're looking at CPU and memory. It's just a different view of the same stuff that we saw on OpenShift's actual UI. And the CPU usage is pretty high. So that's the reason for that, is that I'm artificially increasing it actually, just so that there's something to look at there. And so you've got the, and I think there's also a way to deploy Jaeger as your APM component. I haven't done it in this case, but that's also possible. So that'll be the third component. And this is great. This is out of the box stuff that you get if you have OpenShift. But the problem is when you want to start troubleshooting an issue, then you either need multiple monitors, or you need to start doing something like this where the screen is split two ways. Where's my Grafana gone now? There. Because if you're looking at what happened here, for example, then you can go and select that time range, and then you get your logs. You might even have to zoom out so that you can see properly. Same thing on this side. And then you have to set the same time range over here, to go and set it to a specific time range, which I've got there is about 18:36. So it's more or less over here. And you'd have to do the same with your third system, your APM component. And the same somewhere else with some other component, and it starts becoming very cumbersome. You might even need multiple people doing it, because multiple people know the various systems individually. So it starts becoming very painful. So, of course, it starts getting a bit simpler when you've deployed OpenShift logging. And if we look at the components in that namespace, sorry, not OpenShift logging, ECK. So I'm going to deselect OpenShift logging and monitoring and select Elasticsearch. This is where I deployed ECK in a namespace called Elasticsearch. We've got the APM server that's responsible for collecting APM events from the APM agent that's running in my demonstration Pet Clinic app, which is this one. And then Elasticsearch is a data store. It's a distributed key value store and full text search engine. Filebeat collects logs from all the pods running on the OpenShift cluster. Heartbeat is the uptime monitoring component. It can monitor HTTP status codes. It can check TCP connectivity. It can do ICMP echoes. Kibana is the front-end GUI for doing searches and analysis and that kind of thing. MetricBeat collects system metrics. The system module is the only one I've enabled. So it's collecting things like CPU, memory, disk I/O. It's also got other components. For example, there's an Apache component that'll hook into Apache's APIs and pull metrics directly out of Apache itself. It's got hundreds of them. There's another one, a MySQL component that'll hook into MySQL's internal monitoring metrics collection interfaces and collect internal metrics from MySQL, for example. I'm only using system here. And then PacketBeat is the network monitoring tool. That's like having Wireshark running and sending its data off something. And then finally, I just put Pet Clinic in the same namespace for simplicity's sake, but Pet Clinic's also there. That's the demo app. So what does observability look like? Once it's deployed, you can see this is now the observability overview page. I'm going to go through each of these quickly. So logs is the logging component. We've got metrics, APM, and uptime. So with logs, you can see this is the overview. It'll show you, bucketed by time range, the number of logs that happened in each bucket, and you can view the logs in the logging app. And there we can see the pet clinic logs coming in. It's definitely by far the most active at the moment. You can stream live. And you can search as well. So what was that query? Crash controller. So I can search for crash controller. And we'll see all the errors that are coming out. So, and then these other settings are non-free, so I won't show them. I'm only showing the free components of the stack right now. So that's logging. So this is equivalent to tailing log files. If I jump back to overview, we've got metrics here. You can see CPU and memory, traffic in and out. You can view an app. I'm going to change this to Kubernetes pods. CPU is fine. I'm going to group by namespace. You've immediately got a cruising altitude view of your entire infrastructure, split up by namespace and container, or namespace and pod. And then, you can say, well, let's have a look at this one. Let's view the logs for that component. And immediately we're seeing the logs for that pod. So, so these observability features are all integrated. You can hop from one to the other seamlessly at any time, all under one screen, which is pretty cool. Sorry, we did look at that already. And then I'm going to come to APM last. Then there's uptime. So I've got that heartbeat component that you saw. That's running here somewhere. We're checking the Elastic website for a redirect. And in this case, there is a redirect, so it shows us up. And the reason for that is that we're hitting an HTTP URL and it immediately redirects to HTTPS. So that's up, that's great. We're looking here, we're going to a specific web page and we're testing for the existence of a string on that page. In this case, the string does not exist, so it's down, even though the web page itself is up. We're looking for a 200 response on LSD's website. I suspect that might have been a blip in my internet connection. I don't think the site was actually down. Here, we're looking for a 200 response on the HTTPS portion of the website. Here, we're looking for a 200 response on my pet clinic demo app. Here, we're looking for the same thing once again. Here, I'm just pinging the AWS global server network. It was down a little bit earlier, not sure why, maybe the ping's timed out. And at the bottom here, we're testing actual TCP connectivity to my local DNS server and to Google's DNS. So those are the sort of things that Heartbeat, it's quite versatile. You can do those kinds of things. And there's a new feature coming in Heartbeat. It's in beta at the moment, which you can actually test the full usability flow and user experience of a website. So for example, let's say you're running a shopping site. You can test somebody pulling up the website, typing a search, clicking on an item, adding it to their cart, and running through the whole checkout process. And you can check the uptime, in inverted commas, the availability of each of those steps using a single configuration for Heartbeat. So Heartbeat's, I think when Heartbeat was first released, it could only do uptime checks. Is this website responding? But it's become a fully fledged tool now. It's become quite a cool thing, actually. So, for example, yeah, this uptime app gets finicky sometimes. It hangs. So I'm just going to reload it. So once you've got this data, you can do things like, oh, it's just not playing well. There we go. So for example, not only has it checked the 200 response coming from our website, it's also telling us that the certificate expires in a month. And you can do alerts on that kind of thing as well, which starts to become very useful when you've got a massive fleet of servers that all have TLS enabled. And it's, you know, you can do it all here in this uptime monitor. The other thing it tells us is that this heartbeat is running in the ZA North Pretoria AWS data center, which incidentally is in my study. And the reason that you'd want to know where the heartbeat monitor is running is if you can imagine a globally distributed network of systems. Perhaps you've got, you know, the service itself centralized somewhere, put behind Cloudflare load balancers globally to improve response time. If the heartbeat monitor in Southeast Asia suddenly starts returning no connection or 504 errors from your app, it could imply, you know, maybe the Great Firewall suddenly started blocking something, and you know exactly where to go and look to investigate the issue. So you need to know where your heartbeat monitors are. You might want them in various network segments, in various data centers, various countries, and various continents. So that's the reason for that. And then finally, the final component of observability would be APM. So APM, what I did was I instrumented this app, and it was surprisingly simple to do. It didn't even require a source code change. I wouldn't know where to look for the source code for this. It's probably somewhere in GitHub. But to instrument the pet clinic app, it was a simple case of adding a set of environment variables that sort of tells the agent where it must send the data. So it's going to the APM server on HTTPS 8200. I'm saying the environment's a test environment, and we're doing debug logging. And then over here, where is my init container? Here, there's the init container. That's all there is to it. So when this pod starts up, it pulls a Docker image. It executes it with those parameters. It mounts the agent configuration, and that's it. I didn't have to go and change the source code of the app. I took the app, I deployed it, I added these parameters to the deployment, started it up, Bob's your uncle, it started doing APM logging, which I was very surprised at. I was expecting to have to you know, fork this app and go and add parameters to the Java source code and add stuff to HTML pages, but I didn't have to do it. It was that simple. So I mean, you can easily instrument existing apps with the APM agent. It was almost mindless. It was so easy. And so I'm just going to hit F5 here a few times to generate some errors. So here is my Pet Clinic app. And if we click on it, you can see we've got transaction duration over time, requests per minute. That's the Selenium script that's smashing it in the background. We've got a transaction error rate. So every now and again, that Selenium script hits the error page that's designed purposefully to generate an error. You can see here, expected controller used to showcase what happens when the exception is thrown. So that's what we're seeing there. And then time spent by span time. And what's really cool about this is you can go and say, well, I only want to see the 500 errors. And we pivot to seeing errors only. And then you can drill down on the transaction itself. And then, sorry, this Zoom panel is in my way. You can focus on this. And you see all of this metadata pertaining to that particular APM event. It was a GET request. It was not encrypted. It was on a plain text connection. There's the user agent. There's the host, the referrer, the request and response headers. It's all there. You know, it's just the amount of detail is astounding that you get out of this simple instrumentation. But what you can also do that I thought was pretty cool is if you look at something like this one, This app's backed by a simple database. For example, you can go into the app, you can go find owners. You can click on the owner, it shows his pets, you can add a visit, so it's all database backed. And you can see the actual database requests here. It was picked up from the APM agent. And if you click on it, you can see the database call that was made, the SQL statement, and you can see metadata around it. And it was done 18 minutes ago, and it was a 2.9 millisecond call. It was 77.7% of the transaction. So now that we've got all of this data, and it's all in Elasticsearch, if you look here, sorry, this zoom bar is really in the way. You can see here's FileBeat, that's gathering logs. We've got MetricBeat gathering metrics, Heartbeat gathering uptime information, and those are the APM indices. So once you've got all of this data in one place, and it's all in our Elasticsearch data store, you can do something like this, which is to build a single dashboard that displays all of that data in one place. So we've got event type on the left. So it turns black and white when it's refreshing. We've got event type on the left, so you can see the errors is that small slice there. We've got APM event, which is the red line, and CPU usage per pod on the green. And over here, we've got ping response times. So this is APM data. We've got ping response times, that's uptime data. And we've got metric data, memory usage by node, CPU usage by node, network in and out, memory stats by container, the top CPU intensive pods, the top memory intensive pods, and logs, all in one place. And I'm just going to turn off auto refreshing. And then what you can do is you can say, well, I'm only really interested in my app that I've instrumented, which is Pet Clinic. And then suddenly you're looking only at the Pet Clinic data. And you can see there was when I hit refresh a few times on that page to generate a bunch of errors. There's a little spike there in the error rate. And when I was artificially increasing the CPU usage, you can see it here. And finally at the bottom of the logs. So those are all of, so I can go and zoom in on this section. So I've changed the time period there. And then we can say, we'll maximize this. What was happening then? What were the logs? What did the logs look like at that particular moment? And you can see those are all the errors that we were seeing. And I think the point here is, having OpenShift means that you can deploy observability. It's very easy to do, and it's usually included as part of OpenShift, and you run a quick Ansible and off you go. But you can't do this. You can't have it all in one place under one pane of glass. You have to have, it becomes very cumbersome and very time consuming to try to troubleshoot and analyze when something goes wrong with your application. And I think that's about all I have to say about that.